Hi kiddos, this is Unit 5, Lesson 32, Day 3, textbook page 338. Alright, so today we are going to be talking about ideas about properties of quadrilaterals. We're going to be talking through these problems and then writing answers down. Please do not just copy my answers. I would like for you to pause the videos after each question when I ask you to. Write down your work, show your work, and then continue the video and make corrections as needed, just like we did in class. Don't simply copy off of me and think, it's an easy way out. Remember, I'm getting you ready for 6th grade, not just passing the time, but getting you ready to go. It's less than 9 weeks and you'll be middle schoolers, so make sure you're studying and doing your part the way that I'm doing mine. So in number 9, all quadrilaterals are either convex or concave. A convex quadrilateral has all interior angles less than 180 degrees. A rhombus is an example of a convex quadrilateral. A concave quadrilateral has at least one interior angle greater than 180 degrees. The quadrilateral below is an example of a concave quadrilateral. If you're like me, that sounded like Charlie Brown's teacher talking to me. Wah, 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 wah. And I have to go back with a highlighter and highlight this stuff to help it make sense to me. So let's do that now. Let's talk about these. It says all quadrilaterals are either convex or concave. So I'm going to start with convex. So I'm going to highlight the word and then I'm going to highlight the talk about it. It says a convex quadrilateral. So a shape that is considered a convex quadrilateral is going to be a four-sided shape and has all interior angles less than 180 degrees. All interior angles. That means these angles inside. We're measuring the inside angles. It says a rhombus is an example of a convex quadrilateral. So let's talk for just a moment about this. We're talking about the measure of the inside angles. Remember that a rhombus has two acute angles that are opposite of each other. So this is acute and this is acute. Do you remember what acute means? Acute means that it is less than 90 degrees. Well, then it also has two obtuse angles that are opposite of each other. So the angle at the top and the angle at the bottom, right here and right here, are both obtuse angles. But none of them are going to be greater than 180. Now, one thing that so far has not been mentioned in this unit at all that I'm a little concerned about, you all know how I teach and what I do. We have acute angles, which are your angles that are less than 90 degrees. You have a right angle, which is like the edge of a square, which is exactly 90 degrees. You have an obtuse angle, which will fall between 91 degrees and 179 degrees. But then on the EOG, if you were to be taking that, you would also have two other types of angles possibly mentioned that has not been mentioned in this unit. One of them is a complete straight line. Let's say that, excuse my highlighter, I just don't want to change. Right here was where these two lines met. We have a line here and a line here. The measure from here over to here would be exactly 180 degrees. And that would be called a straight angle. So, for example, I have one coming this way and one coming this way. Those two together would be 180 degrees. Well, let's look for just a moment. Too bad I do not have angles already on here. But for the sake of, my babbling, I want to show you right here. Do you see that this would be a right angle right here? So now let's say that I had two of these. And it was this way. And you have 90 degrees and 90 degrees. 90 plus 90 equals 180. So that is where you get the 180 degrees in a straight angle. Then this right here, what they are calling a concave is greater than 180. Let's go back to this right here. And I'm going to highlight the word concave with a different color just because I can. And it says a concave quadrilateral has at least one interior angle greater than 180. The quadrilateral below is an example of a concave quadrilateral. So when we see this right here, this is greater than 180. So it goes from like 181 to 359. This concave, until this year, really, until we started using iReady, then right here, this concave, this would have been called a reflex angle. So you have a reflex angle there, which is greater than 180 and less than 360. And then right here, you have a straight angle. And so that is always, always, always 180 degrees. Where a right angle is always 90 degrees, a straight angle is always 180 degrees. So I just want to toss that out there to you so that you knew the terminology if it were to be presented to you later. All right, so let's move on just a little bit. Categorize concave quadrilaterals, convex quadrilaterals, trapezoids, and rectangles in a Venn diagram. Draw an example of each quadrilateral in the diagram. Now they're wanting you to categorize this into a Venn diagram. Personally, if you were in class, I know good and well you would be coming to me and you would be saying, Miss Fleming, I don't understand what it's asking. Me as a fifth grader, I'm not sure I would have understood what it was asking. So they're wanting you to put these shapes into a Venn diagram that's going to look something like this. And so you're able to draw this in your book, and it's just wanting trapezoids and rectangles in this convex category. You see you have quadrilaterals, everything here around it. Inside of quadrilaterals, you have convex and concave, so there's your two categories. And so here you have trapezoids, you have rectangles, you could also have a rhombus in here, but then over here on the concave, you have a shape like this right here. Alrighty, so pause the video, take time to draw this out, and then we will continue in just a moment. Number 10, Naudret said that a rectangle can never be called a trapezoid. Explain why Naudret's statement is incorrect. It said that a rectangle can never be called a trapezoid. Pause the video, answer the question, and when you resume, you'll be able to make corrections or add to your notes. Possible answers. Since a rectangle has at least one pair of parallel sides, it can be called a trapezoid. So all it has to have is at least one pair of parallel sides to be a trapezoid. A rectangle has at least one pair. It actually has two pairs of parallel sides, so it can be a trapezoid. Now, number 11, please pause the video after we read the question and then write your answer down and we will resume. Describe the properties of a shape that is both a rectangle and a rhombus. Name the shape and use the grid below to draw an example. A parallelogram with four sides of equal length and four right angles. So you could easily have done this right here and been completely correct by just drawing a square. Textbook page 339. Put it together. Use what you have learned about classifying quadrilaterals to complete this task. Part A. Create a tree diagram to show the following types of quadrilaterals: trapezoid, parallelogram, square, rhombus, rectangle. Make sure to include the category quadrilateral. Use information in the table to help you. So I want you to use the information in the table to draw a tree diagram. And then when you finish, resume the video, add to your notes, and we will move on. Please pause now. All right. I hope that you were able to complete your tree diagram. I'm going to uncover the answer now, the tree diagram, and you can make any corrections that you need. Here's a possible tree diagram of quadrilaterals, trapezoids, parallelograms, rectangles, rhombus, and squares. You have seen this many times last week, and here it is again. You will need to know about the tree diagram. Part B. Write a statement that is always true about the relationship between squares and rhombuses. Please pause the video and write your answer down, and then we will resume in just a moment. All right, welcome back. Possible answers. All squares are rhombuses. So right here, when you see squares and rhombuses, all squares are rhombuses. Part C. Write a statement that is sometimes true about the relationship between squares and rectangles. Always true about the relationship between squares and rectangles. Pause the video, write your answer, and when you resume, you can make any notes that you need. All right, welcome back. Possible answer. A rectangle can be a square. Okay, so now your homework to help you understand this better and practice a little bit more is workbook pages 361 and 362. So please take your time, work hard on those, and be studying for your quiz later on. All right, kiddos, I miss you bunches. Have a great day.